Hello there.
Hello.
So what are you guys doing?
We're drilling weight out of this device for boom.
So what is this for?
The boom.
The boom. What exactly is it supposed to do?
I have no idea.
You have no idea.
No idea.
All right, can you guess?
No.
No, you can't guess.
I can't.
All right, thank you anyway.
What I'm doing here is making a claw to pick up the tubes, and it's going to work like this. It's going to be attached to a cross beam. It's going to turn sideways like that. And touch the tube from the inside from the inside.
All right. So what are you doing right? So what exactly are you doing to it as far as machining?
I just kind of finished putting a bunch of welds in here, so I'm going to try to think of what next to do.
All right. Thank you.
Pretty much what we are doing is we are drilling holes in the boom. This is part of the claw, and we're drilling lightning holes in it right now.
All right. So this is the innermost extension of the boom.
Yes, it is.
And so, let's see. Where will the claw be mounted?
The claw is going to be mounted right here and right here. And the way it works is that the claws come out like this.
So grab the inner tube from the middle?
Yep.
All right. So how soon do you think you'll actually be done with this?
If we're lucky, we might get done with this before Tuesday morning.
Adelaide, tell us what you're doing there.
So right now I'm going to drill some holes right on here so that I can mount this to the frame. It's going to go up under the frame like this, and then we're going to have two things that are going to come down that look like this, and they're going to hold it to the frame. And then this is our main gearbox. It's going to go in the center of the robot. We're going to have two on the outer sides and then one in the middle, and this is the one in the middle. It's going to drive the rubber wheel, and then we're going to have a belt that's going to go all the way to the Omni wheels. So basically this is just the main gearbox component that I'm trying to work on.
Ian Malpin, tell me something about what you're doing.
Well, this is our elevation gearbox is what we called it. This thing right here will turn our huge gear that will rotate our boom to elevate it, moving it up and down. It's driven by a few worm gears and things to prevent back driving. It'll have two Bainbot motors that'll be mounted here. Right now I'm trying to make it so it's not locked up. There's a weld in here that seems to be hitting the gear, so we're trying to grind that down so that it will turn smoothly. So yeah, funny thing about this is I designed this in AutoCAD, and just for fun I made our big gear, which is supposed to be our strongest gear, out of wood. Everybody thought that was pretty funny. So yeah, this is our elevation gearbox. This is our double extension boom for our robot this year. It consists of three different pieces: the outer, the middle, and then the center, which is having the claw attachment right now. Okay. Basically, it is driven by a gearbox which attaches here. And it has a sprocket goes underneath and attaches to this chain, which is pinned to this part of the boom. So as this is pulled, as it is rotated, the chain actually pulls out the boom. At the same time, there's wire rope that is attached to this part of the boom, which then pulls other strand, the same strand of steel wire. It goes around 4 different shivs at 12-degree angles to allow clearance. And then it's also attached to the inner part of the boom so that at the same time you keep pulling out the center part. Cool. So what are you doing right now? Right now I'm working on the chain attachments to the middle part of the boom, and then after that we're going to start probably working on the wire rope. So do you like this design this year? Yes, I do. It's kind of reminiscent of our first year, and hopefully we can make a huge improvement on how it works. We're trying to make it extremely reliable and easy to repair for brakes.
Well, this is our control box. And here we've got, obviously, the control computer that was given to us. It's essentially a laptop computer. It's we're running Windows 7 this year on it. And we're running LabVIEW. And so we've got that loaded on here. You can see we've got 4 sets of joysticks, so we're doing a tank drive this year. And so left and right side of the robot are driven by these 2 joysticks. And then we have a boom, which has an angle to go up and then an extension to go out. And we have a separate joystick for each of those 2 things. You can see all these are USB controlled, so they all run to a little USB hub down here, which then plugs into the computer. And we have our emergency stop button. And this is another USB to a special little circuit board that has like a little programmable gate array on there to allow us to do all our I/O, analog I/O, digital I/O, that kind of thing. So this year, luckily, we don't have too much stuff. We've got an LED we're lighting as an indicator to a driver. And so that's coming off of here. In fact, that's what we're doing right now. We're going to move that, we're extending it down to here. And what it is, the rules say that you can't extend any part of the robot more than a certain amount away from the robot. And so if we had a boom fully extended at a low angle, it would extend beyond what's allowed and we get a penalty. So to control that, we have a sensor on the extension motor and the angle, the boom angle motor. And so our software knows where it's at all times, and it will limit it automatically. So we know what the angle is, we know what the extension is. We use trigonometry then to make sure we don't go beyond the allowed extension. And if the driver tries to extend it beyond what's allowed, the little LED will light up indicating that, hey, we've automatically limited you, and that's why it's not extending it.
Hello, Mr. Summers.
Hi.
So what are you guys doing here?
Well, we're trying to finish up some of the wiring and bracketing that we're going to need for the robot. We've got it all laid out on a platform that we can actually insert up from the bottom on the robot. It will mount on when the robot frame is done. We've got our remote interface, our I/O interface, converter, our power distribution panel. We've got our Jaguars mounted in a nice space-saving feature here. We've got a nice bracket on here, which makes it look pretty nice. We've got our controller off to the side over here. Our digital I/O is mounted on the other side. So we've got a total of 9 Jaguars that are going to run the motors on our system. We've got a line follower system on here that we're going to use. Actually, it's going to be on the front. We have the line followers on the front so we can actually follow the lines on the field in autonomous mode. We've got an acoustical sensor that we'll have to have mounted. We're making brackets for that now. That'll tell us how far we are from the wall to be able to score with that. We have already tested this system. It works fine, so we're ready to mount it on the robot and wire up the motors.
All right, thank you.
You're welcome.
All right, this is Jonathan, and he is working on a gearbox. So Jonathan, what is this gearbox supposed to do?
This gearbox is to take the boom and extend it for the robot. Here, this is just to cover the sensor. And then in here we got 2 Bainbot motors that run 32 pitch, 16 tooth gears, and some larger 32 gears. And then this one here is just an idler, but this one will run this worm gear here, which then turns the worm gear and the sprocket. The sprocket's going to turn a chain which will pull the middle boom out, and then there will be another cable attached that will pull the center one farther from that. Most recently, I welded this piece on right here. This piece is to allow us to mount the gearbox to the boom. What we're going to do is we're going to drill a hole through here, and there's another one that's going to be on the boom down here. And then we're going to put a bolt through them both, and there's going to be another hole through the back of here. So I think that's about it. Thank you.
All right, well, what's the line sensor? What's the sensor for?
The sensor is a speed sensor that's supposed to calculate how many revolutions that the gears turn, so we can calculate how far out our boom exactly is, so we don't go beyond the maximum diameter.
And how fast is this supposed to work?
It's supposed to go pretty fast. I don't have the numbers off the top of my head, but it's about a 72-to-1 gear ratio. Works pretty well.
All right, thank you. Hello there, Sam.
Hey.
So what do you got here?
What we've got here is the sensor drive box for the 2011 First Robotics season. Right here we're using 2 SIMs
on each side of our drivetrain, which is going to be connected by belts, which will be driven by this sprocket right there. An interesting feature that we have on this year's drive is actually the bearing that we have here, which is currently covered up, but right here you can see it's over 2 inches wide, which is quite large for a bearing. We had to get them custom ordered, and what we actually use it for is spinning our entire wheel assembly. So when it's all said and done, this entire chunk of metal is going to be free spinning, supporting one side of our robot. We have our gear reduction done in 2 stages this year. It's a 12:1 ratio, and using our 6-inch wheels, we're hoping to get roughly 9 feet per second, which is a lot faster than we've ever done in the history of our team. And so we're excited to see how everything turns out this year.
So what kind of wheels are we using?
Well, we're actually using 2 different types of wheels this year. Our standard wheel is the Coulson caster wheel. Normally we use a standard 8-inch diameter wheel. This year we decided to cut it down to 6 for a lower center of gravity for our entire drivetrain. And also on the outside we're using 6-inch Omni wheels. So we're planning on using those to have enhanced turning ability and smoother turning, so we can place the inner tubes better.
All right, thank you.
All right, so this part right here, it's kind of hard to tell because it's on its side, but this is where the boom's gonna go. There's gonna be a bolt going through here, and this is the pivot point for the boom. It's gonna go straight through here. And we're gonna have a gearbox for the boom on this other side, and it's gonna have a big gear going in here that's gonna drive it. It's gonna be supported here. We're gonna have some motor mounts probably on this side. And then down here we have these 3 spaces on either side that are going to be supports for the gearboxes that are going to go underneath the side of the frame. And those are going to be closer to the ground. And then we have...
And what do those gearboxes do?
Well, this is going to drive the 2 Omni wheels, these on the sides. And then these in the middle are going to drive the 2 rubber wheels. And these are going to have bigger gearboxes, because we need the 2 sim motors to be able to drive it faster and get all the torque that we need. And these aren't going to have any motors because they're going to be driven by a belt that's going to come through down here. And then this on either side is for our bumper supports. So these come out, I guess, making the robot, 27 inches, which is about what we need it to be. And then, let's see what else is there. Oh, our electronics is going to have brackets that come out here and then come down, and we're going to set it inside here so that we can mount all of our electronics. Our battery is going to be back here, our Victors, our Jaguars, and then the computer and stuff is going to be up here because we need room for the boom to be able to swing in here. Not really too much else going on with the frame.
All right.
Other than supporting those things.
Thank you.